What if I told you that an LLM evaluation can tell you that your AI system is getting better while your actual users are telling you the opposite? Hi everyone, I'm Prachit, and in this video, we are going to break down one of Spotify's engineering team's really interesting ideas. Better experiments with LLM Evals, a funnel, not a fork. So, the big question we are going to answer is, should we use LLM evaluations instead of A-B tests when we are building AI products? And Spotify's answer is actually more interesting than a simple yes or no. We'll look at three things. First, what LLM evaluations are actually good at. Second, why A-B testing is still necessary for measuring real user impact. And third, and this is the really interesting part, how can you use the results of your A-B test to actually calibrate and improve your LLM evaluations? So, by the end of this video, you should have a simple mental model for when to use an LLM judge, when to run an experiment, and why these two approaches work together then separately. So, before we get into Spotify's funnel, let's first understand the problem they are trying to solve. Why are A-B tests alone not enough when we are evaluating modern AI systems? So, Spotify says about 12% of A-B tests end in a ship positive result, but 64% still produce valid learning. Experiments are valuable. The problem is experiment bandwidth. If we can identify obvious quality failures before users even see them, why spend an experimenting slot discovering them? For Spotify, this is a really big deal because it has one of the best recommendation systems in the world for music and podcast streaming. Let's move on to verification versus validation. So, let me tell you what verification asks. So, verification asks us, did we build what we intended? Is the response relevant, coherent, and aligned with the task we are supposed to do? LLM evaluations are good at this, but validation is different. Validation speaks that did real users actually benefit from this feature? That requires online evidence. A 9 out of 10 LLM score is not the same thing as a 9% business improvement. So, verification should not be clubbed as validation in this format. Now, our funnel. Imagine 100 candidate prompts, models, retrieval strategies, or agent configurations. We don't want a full online experiment on all 100. We first use an LLM judge to filter obvious failures. Then only the strongest candidates consume the A-B test bandwidth. That is the funnel. We work towards eval first and then the experiment second. This is the answer which is chosen by many MNCs. Now let me tell you a recommendation example. Imagine a recommendation that is technically good content but completely wrong for this listener. An LLM judge can surface patterns like poor relevance, intent mismatch, or trust-breaking behavior. Those patterns can generate product fixes, but the judge still cannot provide the fix, reduce churn, or increase long-term engagement. The experiment is still needed. What is the proxy trap? Well, Spotify explicitly describes evals as proxies. The score stands in for an outcome we actually care about. If the judge says variant A is better, users might improve, nothing might change, or outcomes might get worse. Each case tells us something different about the evaluator. The disagreement is useful calibration data. Now, what is calibration here and how a proxy trap can be reduced? So, to close the calibration loop, the most important idea is after the A-B test, run the LLM evaluation on the experiment data itself. Did the version of the judge preferred actually perform better with users? If yes, confidence in the evaluator process increases. If no, that gap is diagnostic gold. We have learned something about what the judge is measuring and what the product actually values. So this loop is something which is used for testing all of the LLM validation and evaluation scenarios for all the new features. How do we implement guardrails in this? So Offline evaluation measures the dimensions we explicitly choose. Production has side effects we may not anticipate. Spotify says around 42% of launch experiments are rolled back to prevent regressions in secondary metrics. These are kinds of effects an offline eval can miss. So, all the evaluations which are performing once went to production can produce results which are not needed or which were not intended to. So, to roll back these features is an important part of the process. So, what is the framework which Spotify uses to prevent this? So, we ask what question you are trying to answer. Quality, eval. Candidate selection, eval. Real user impact, A/B test. Unintended harm, guardrails. Does the evaluator actually predict value? Calibrated against online outcomes. Evidence should become stronger as the decision becomes more consequential. Nuances. So Spotify is not saying A/B tests are obsolete for LLM evaluations, but this article is about making experiments smarter. The later Spotify discussion sharpens the boundary. LLM predictions can potentially stand in for human outcomes, but only under assumptions. That is very different from saying an LLM judge is automatically casual. The safe takeaway is efficiency plus calibration, not A/B tests are dead. So, as a final takeaway from this article, we identify that LLM evals and A/B tests are fork in the road. They are a feedback system. Evaluate and filter candidates, experiment with real users, and then measure outcomes. We then calibrate the evaluator using what happened online. Over time, this makes most the evaluation system and experimentation smarter. So this is how evaluation system is being implemented by Spotify as per the article which they have published. Keep subscribing to the channel and like the video to see more such deep dives onto different research articles and different programming concepts. Thank you.